Hi guys, I trust that you're feeling well and awesome. Welcome to this video on grade 10 mathematics, and in this video we'll have a look at factorizing the difference of two squares. Now this is the second video in a series of videos that's going to cover factorization for grade 10 and for basically any grade 11, 12 that needs access to this type of content, because factorization is one of those sections of mathematics whereby if you don't get the basics in grade 10, it's going to come back to haunt you in grade 11 and 12. So this is not just for grade 10 learners only. If you're doing grade 11 and 12, or even grade 9 for that matter, this is still applicable to you as well. So in this video, we'll have a look at what the difference of two squares is, why do we have a difference of two squares, how to identify it, and then most importantly, how to factorize the difference of two squares. Now, this is the second video in a series of videos that covers the basics on factorization. So stick around and let's get into it. We said in the previous video as well that factorization is the process of finding the factors of a given expression. Now, not so much the factors in terms of numbers, but also the factors in terms of, well, just terms. And the method of determining the factors or the products depend on the type of equation that is presented. In the previous video, we had a look at factorizing the common factor. If you haven't watched that video, I would highly suggest that you check it out, because some of what we will do today will involve the common factor that we looked at in the previous video. I will leave a link down in the description for you so that you can have access to the video and to the entire playlist as a whole. So we said when we're looking at a common factor, we have two or more terms in an expression. This is just a revision of what we did last time. So we said for the common factor, it does not matter how many terms we have, but we need to have at least two terms. And we said with those two terms, what needs to happen is they need to have a highest common factor. Now, I'm not going to go into the details on how to factorize a common factor. If you'd like to have a look at that, then please, like I've mentioned, look at the previous video that we've done on factorization for common factor, and then come back to this one. So we said there's different methods of factorizing. We've done the common factor yesterday, or in the previous video. Today we'll have a look at the difference of two squares. We also have the sum and difference of two cubes, which we'll present in another video. Grouping will also be in another video. The trinomial will also cover that in another video. So let's get into what the difference of two squares is. Now notice that the difference of two squares is sometimes abbreviated to dots. So in the event that you see this in a textbook or a different video or anywhere on the internet for that matter, just know that we're talking about the difference of two squares. Now, the difference of two squares is used when we've got two perfect squares. Notice we've got only two terms here, and those terms have to be perfect squares. What else? They need to have different signs. Now, remember we said that a perfect square is a term whose square root, notice perfect square, the square root of that specific term is a rational term. So what do we mean by this? If we have 4 is a square root. Why? Because if you press the square root of 4 on your calculator, you get 2. Now, 2 is a rational number. It's a rational term. If you do not know what a rational number is, I would highly suggest that you go check out our video on the number system. It's the first video for grade 10. Please have a look at that one and then come back so that you can understand what we mean with all of the terminologies. I can also see if I have something like, let's say 16 over 9. This is still a perfect square, because if I find the square root of 16 over 9, this is equivalent to saying the square root of 16 divided by the square root of 9, which will actually give me 4 over 3. So take note that a perfect square does not only have to be a number, it can be a fraction. For as long as when we press the square root of that specific fraction or term, we get a rational number. Now take note of something. We're looking at numbers here. But terms or variables can also be perfect squares. For example, k squared is a perfect square because the square root of k squared will just give me k. Now, I can say, if I have something like y to the power 4, this is still a perfect square because the square root of y to the power 4 will actually give me y squared. So what are we saying here? If I could take something like x to the power 6, this is still a perfect square, because the square root of x to the power 6 will give me x to the power 3. In essence, what we're saying is a term or a variable does not only have to have a an exponent of 2. For as long as the exponent is an even number, that specific term is a perfect square. Please take note of that. As we have mentioned, for terms with variables, a perfect square is a term whose exponent is an even number. I can have something like p to the power 12. Because the 12 is an even number, this is a perfect square. I can have, for all we know, m to the power 64. This is still a perfect square because the exponent is an even number. Please take note of that. Now, examples of expressions where we can use the difference of two squares. Notice that in all of these expressions, we only have two terms. As we've mentioned, we need to have two terms. In all of these expressions, those two terms are perfect squares. In all of these expressions, those terms have different signs. So you would notice 4 minus x squared. 4 is a perfect square, x squared is a perfect square, there's a minus, so that's a difference of two squares. Y to the power 4 minus 16, y to the power 4 is a perfect square, 16 is a perfect square, there's a minus sign, it's a difference of two squares. K squared minus p squared. K squared is a perfect square, p squared is a perfect square, there's a minus, they've got different signs, it's a difference of two squares. And you can see the pattern in the next two expressions also. M squared minus 1. M squared is a perfect square. 1 is a perfect square. There's a minus sign in between, or they've got different signs, so that's a difference of two squares. Negative n squared plus 64. So n squared is a perfect square. 64 is a perfect square. They've got different signs, so there we have it. It's a perfect square. If I have something like p squared plus q squared, this is not a difference of two squares. Why? Well, you might say, but we've got two terms. Yes, they've got perfect squares. Cool. But then you would notice that we do not have different signs. Both p squared and q squared are positive, so this does not apply to the difference of two squares. Please take note of it. In fact, we have no method of factorizing this. You cannot factorize such an expression. Okay, let's get into the purpose for today's lesson. How do we factorize the difference of two squares? First, we need to check if there is a common factor. Once again, as I've said earlier, if you did not watch our video on the common factor, please go back and watch the video on how to factorize a common factor. Then you come back to this one because it's essential that you understand that all the other forms of factorization rely on your understanding of the common factor. So if there is a common factor, you need to factorize the expression using the common factor method that we've spoken about in the previous video. Now we need to open two sets of brackets. One with the positive sign, one with the negative sign. The order does not matter. You can put negative and positive or positive and negative. It does not matter. We need to find the square root of the first term and write the answer as the first term of each of the brackets. So for example, if I've got x squared minus y squared, according to the instruction number 2, I need to open two sets of brackets. There's a minus, there's a plus. I need to find the square root of the first term. So the square root of x squared is just going to give me x. I'm going to put this x here and the x there. I also need to find the square root of the second term. So the square root of y squared is just y. Then I need to put the y there and I need to put the y there. And I'm done with the factorization. So instruction number 4 says we need to find the square root of the second term. Then write the answer as the second term of each set of brackets, as I've done in the example just now. Alright, enough talking. Let's look at the examples and see how we can actually do a practical application of factorizing a difference of two squares. So we've got k squared minus 16. Let's write this down. So, whoops, wrong color. We've got k squared minus 16. So according to my instruction, let me check first. Do I have a common factor? No. Well, you might argue to say, yeah, but we've got 1 as a common factor. Technically speaking, if we have 1 as a common factor, we don't need to write it as a common factor. We've got two terms. Are these two terms perfect squares? Yes, they are. Do they have different signs? Yes, they do. So I can go ahead and I can factorize my difference of two squares. I'm going to put a positive there, I'm going to put a negative there. The square root of k squared is k. So I'm going to put k there and I'm going to put k there. The square root of 16 is 4. So I'm going to put 4 there and I'm going to put 4 there. Just like that, you are done factorizing. Life is great. Let's look at the next question. So in the next question, we've got 4 minus 25p to the power 4. Okay, let's go back to our writing pad. And we have got here 4 minus 25p to the power 4. Do we have a common factor between these two terms? No. So there's no need to check the common factor factorization. Do we have two terms? Yes, we do. Are these two terms perfect squares? Yes, they are. Do they have different signs? Yes, they do. So this is going to be a difference of two squares factorization. Let me open two sets of brackets. So the square root of 4 is going to give me 2. So I'm going to put 2 there, I'm going to put 2 there. Let me put a negative and a positive. The square root of 25p to the power 4, this is going to give me the square root of 25 is 5. The square root of p to the power 4 is going to be p to the power 2. So we've got 5p to the power 2 and 5p to the power 2 there. Wonderful, we are done factorizing it. Let's look at the next question. So in the next question, we have x cubed minus x. Interesting one. So let's scroll down for some room. We have x cubed minus x. Looking at this, do we have two terms? Yes, we do. Are they perfect squares? Well, no, they're not. But now let's check, do we have a common factor? Yes, our common factor is x. So let's put x outside of the bracket. And now let's do our common factor factorization. We take the first term divided by the common factor, and this gives us x squared. So we've got x squared there. We take the second term, we divide it by the common factor, we get negative 1. So let's put negative 1 there. What do you notice about the expression so far? If you check carefully, this is actually a difference of two squares. Why? The two terms are perfect squares. They've got different signs. So I can factorize this. So I leave the common factor where it is, and then I open two set of brackets. Let's put plus, let's put minus. We are then going to say the square root of x squared. This is going to give us x. So let's put x there, let's put x there. Then the square root of 1, this is 1. So let's put 1 there, let's put 1 there. Wonderful, brilliant, we are done. And let's move on to the next question. In our next question, we've got an interesting question as well. Negative open bracket p plus 2 close bracket squared plus 1. Let's look at this one. So let's scroll down. We've got negative open bracket p plus 2 squared close bracket. Let's see, this was plus 1. Yes. Okay, now when you look at this specific question, your first thought might be, hey, I see brackets, let's multiply out the brackets. You'll actually be doing a lot of work here. Let's check something. We have got two terms here. 1, 2. There's two terms. These terms have different signs. There's a negative, there's a positive. Both these terms are perfect squares because the exponent of 2 up here tells me that this is a perfect square. So I could use the difference of two squares to factorize this. What I'm going to do is I'm just going to swap them, wrong color. I'm just going to swap them around so that I have the positive term first and then the negative term second. Then what I'm going to do is, let me open my brackets. I'm going to put minus there, I'm going to put plus there. Remember, the order doesn't matter. The square root of 1, this is going to give us 1. So let's have 1 there, let's have 1 there. Next, the square root of p plus 2 squared is going to give me just p plus 2. So let me put here p plus 2 and let me put p plus 2 there. You can you could simplify the like terms by saying, okay, 1 plus 2, this gives me 3 minus p. And then 1 plus 2, this is going to give me 3 plus p. Wonderful, We are done. Life is great. Let's move on to the next question. In the next question, we've got negative x squared plus 4. Okay, let's look at this one. Let's scroll down for some room. We've got negative x squared plus 4. Do we have two terms here? Yes, we do. Do they have different signs? Yes, they do. Are they perfect squares? Yes, they are. So we've got a difference of two squares here. What I'm going to do once again, just like in the previous question, I'm going to put the positive term first and the negative term second. Now what I'm going to have now is two sets of brackets. One with a plus, one with a minus. This is a terrible bracket. Let's do it again. Awesome. There we are. So, now for finding the factors. The square root of 4 is going to give me 2. So I'm going to have 2 there and I'm going to have 2 there. The square root of x squared is going to give me x. So let me have x here, let me have x there. Now there's a second technique you could have used here to factorizing this. We could say, okay, if I have negative x squared plus 4, let me take out a common factor of negative 1, then remain with x squared minus 4. Now, you could also go ahead and notice this is a difference of two squares. The square root of x squared gives you x. Let's put plus and minus. The square root of 4 is 2, and then we add the 2's. This is exactly the same as the answer that we got above. I hope that this makes sense. I hope you guys are enjoying the content and that you're finding it useful. Let's look at I believe it's the last question. Yes. We've got y to the power 4 minus 100. Okay. Let's look at this one. So we've got y to the power 4. That's a terrible 4. So y to the power 4 minus 100. Okay, so what we need to do here is we need to open two sets of brackets because we've got two terms. Both of them are perfect squares. And they've got different signs. So let me put a y here. Let me put a y here. Because the square root of y to the power 4 is y squared. So I actually need y squared there and y squared there. So just to write this out, the square root of y to the power 4 is going to give me y to the power 2. The square root of 100 is going to give me 10. So let me put negative 10 here. Let me put positive 10 there. Wonderful. Looking at the first bracket, this is not a difference of two squares, so we can't factorize it any further. We are done with our factorization. One thing I forgot to mention to you, in all of these examples that we've covered, there's a way to check whether your answers are correct or not. And for you to do that, let's take, for example, the y to the power 4 minus 100. To check if your factorization is correct, you could just multiply out the brackets. So let's see. Y to the power 2 times y to the power 2, that's going to give you y to the power 4. Y to the power 2 times 10. Okay, my writing is a bit ugly, but anyways, let me put this on the next line. So let's get rid of this and put it on the next line. So initially we said y to the power 2 times y to the power 2 gives us y to the power 4. Y to the power 2 times positive 10 gives us a positive 10 y to the power 2. Negative 10 times y squared is going to give us negative 10 y squared. Then negative 10 times negative 10, this is going to give us negative 100. We've got like terms, these are going to cancel out. You remain with y to the power 4 minus 100. And this is what we had initially in our expression. So therefore, our factorization is correct. If you don't understand how I did the factorization, the multiplication out here, please check out our video on products, grade 10 products, and then you'll understand exactly how the multiplication process works here. I hope that this video was informative. I hope that you guys understand now how to do the difference of two squares factorization. I hope that you enjoyed the video and that you learned something new from it. If you did, please give us a like, give us a thumbs up, subscribe to the channel, click on the bell icon so that you never miss an update every time we upload a video. Most importantly, don't be selfish. Share this video with others so that they can benefit from the same knowledge that we are learning here. If you have any comments, suggestions, please do leave them in the comment section. If you have any requests for specific topics that you'd like us to cover, please leave them in the comment section. Until then, enjoy the rest of your day. Have a wonderful one. Ciao.